The journey of a HEPA air purifier begins in the molding hall, where high-strength ABS and polycarbonate pellets are In the pre-filter section, nylon mesh is cut into precise geometry to trap large particles like hair and dust. Activated carbon sheets are pressed into porous blocks that absorb VOCs and household odors. The True HEPA H13 filter is formed by pleating ultra-fine microfiber sheets that capture particles as small as 0.3 microns. The filtration module enters a sealing station where edges are bonded to prevent air leakage. A high-efficiency DC brushless fan is assembled with precision-balanced turbine blades to ensure quiet operation. The fan module is mounted inside the central airflow chamber, where rubber dampers isolate vibration and reduce noise. Laser-based PM2.5 sensors are calibrated inside a controlled dust chamber to ensure accurate air quality detection. Printed circuit boards are produced in the electronics hall, where micro-soldering robots mount resistors, microchips, and capacitors onto rigid PCBs. The interior airflow chamber is aligned with the filter frame to guarantee a perfect air seal between stages. The top control interface panel is assembled with capacitive touch buttons and a slim LCD or LED status display. The airflow direction louvers are molded and inserted, allowing purified air to exit in a stable, well-distributed stream. A motor controller is installed to regulate fan speed, airflow pressure, and overall energy efficiency.
Wiring harnesses are connected, bundling sensor lines, fan power, and display cables into neatly organized channels. Before assembly continues, the inner chassis is secured with vibration-absorbing mounts to ensure smooth airflow and low operational noise.
The filter door panel is molded and fitted with magnetic latches for fast, tool-free replacement.
Airflow accelerators, curved aerodynamic guides, are installed to reduce turbulence and increase CADR efficiency.
The internal components are secured with structural screws, using torque-controlled drivers for consistency. A soft peripheral gasket is added around the filter frame to prevent bypass leakage and maintain sealed airflow paths. The power supply module, typically a compact AC to DC converter, is mounted in the lower chamber. UVC disinfection modules, if included, are safely enclosed inside a shielded channel to prevent light leakage. The rear housing panel is attached, completing the primary structural frame of the purifier.
The filter module is inserted for the first fit test, sliding smoothly into the front compartment to verify alignment and sealing pressure.
The purifier's outer frame undergoes a structural rigidity test to ensure the housing maintains shape under long-term vibration and airflow pressure. The main fan chamber is airflow tested with calibrated probes to confirm resistance levels and internal pressure zones. Louvers are opened and closed repeatedly to guarantee consistent friction levels and smooth operation. The UVC module, if present, is verified with light detection equipment to ensure zero leakage outside the shielded path.
The HEPA module undergoes airflow resistance measurement to balance filtration strength with energy efficiency.
Carbon sheets are checked for uniform density to ensure equal odor absorption performance across all units. The display panel lights up for the first time as diagnostic sequences confirm every icon and sensor indicator.
Sound level testing begins as the purifier runs at multiple fan speeds inside an acoustic booth. Before moving to the next stage, the purifier undergoes enclosure pressure testing to verify airtight seals around the internal airflow chamber.
The rear intake grill is added and checked for proper airflow dispersion across the entire HEPA surface.
The purifier is run at low-speed mode to ensure silent operation and steady airflow through the multi-stage filter stack. To verify structural durability, the purifier body is twisted slightly in a torsion test rig to simulate long-term handling stress.
Temperature control tests ensure the motor and electronic modules remain cool during extended operation.
Power consumption testing confirms efficient energy use across all fan modes. Each purifier undergoes surface reflection inspection under angled LED bars to detect micro defects invisible under normal lighting.
To ensure durability, the purifier's touch panel is tested through thousands of simulated taps and swipes.
Filter replacement simulation is performed to confirm users can remove and reinstall modules smoothly.
Electrical safety tests ensure each unit meets insulation and grounding standards before global distribution.
The purifier's internal wiring is visually inspected to ensure cable routing remains secure during operation. Each purifier undergoes a tilt stability test to prevent tipping hazards in home environments.
Anti-static testing is performed to confirm the ABS-PC housing resists dust accumulation from electrostatic charge.
Before cosmetic approval, the purifier undergoes a microfiber wipe-down to remove any remaining oils, dust, or production residue.
The purifier enters a long-duration runtime test to validate stability across continuous 8 to 12-hour operation cycles.
Next, a high-speed airflow test evaluates maximum KDAR performance under open output conditions.
The unit is cycled between minimum and maximum fan speeds to ensure smooth, noise-free transitions.
Power surge protection is verified to ensure safe operation during electrical fluctuations.
To mimic real home conditions, the purifier is tested against humidity cycles that challenge internal electronics and filter materials.
The HEPA filter is removed for mid-test inspection to check pleat integrity after prolonged airflow exposure.
Noise level validation ensures the purifier meets strict decibel targets across all modes.
With internal components validated, the purifier enters cosmetic inspection to ensure perfect alignment between exterior panels.
Airflow distribution is measured across every vent opening to guarantee even air spread from the top outlet grill.
Devices are wiped with anti-static fluid to further reduce dust attraction once they reach consumer environments. The purifier is power cycled repeatedly to ensure seamless startup, shutdown, and auto-resume functions.
The sensor calibration module rechecks PM 2.5 readings to confirm accuracy after heat, humidity, and vibration testing. Color matching inspection ensures every unit shares the same tone and texture across ABS and PC components.
Rubber feet are installed to prevent sliding and reduce resonance noise on hard flooring.
Before packaging, each purifier undergoes a visual distortion check to ensure no warping or unevenness appears on the ABS PC outer shell. The activated carbon layer undergoes odor removal simulation using safe, controlled gas mixtures. Internal wiring and connectors are gently pulled and flexed to confirm long-term mechanical reliability.
The purifier's structural fasteners undergo vibration testing to ensure screws or clips never loosen during extended runtime.
Filter access doors are opened and closed repeatedly to validate hinge durability and latch retention force.
Noise harmonics are measured to ensure the fan produces a stable, non-irritating audio signature across all speeds.
Before entering packaging, each purifier undergoes a complete functional verification to ensure all
Electrical leakage testing ensures that all components meet strict global appliance safety standards. Each unit is manually inspected for cosmetic perfection. No scratches, dents, or mold line inconsistencies are allowed. Airflow mapping is repeated one final time using volumetric scanners to confirm CADR values remain within certified tolerance.
Each purifier receives its serial number label, warranty code, and manufacturing batch ID for global traceability. The purifier enters the packaging line, where soft, custom-cut foam inserts are prepared to cradle the device during transport.
Instruction manuals, warranty cards, and filter replacement guides are placed into the accessory slot of each package. The purifier is lowered into the foam cradle, fitting snugly inside its protective shell, with no movement allowed.
Additional protective layers, soft felt sheets, corner buffers, and top pads are added to absorb vertical impact during shipping.
The box is folded and sealed using high-tensile fiber tape that reinforces all structural seams.
Each sealed unit passes through a weight check station to verify correct accessory inclusion before palletizing.
Boxes are transferred to the palletizing zone, where robotic arms stack them into tightly interlocked layers, forming stable towers ready for warehouse distribution. Once palletized, each tower is wrapped with tension-controlled stretch film to stabilize boxes during long-distance transport.
Shock and tilt indicators are applied to each pallet to monitor handling quality during transport. Forklifts lift each pallet and transport it toward the loading dock for container insertion. Pallets are stacked into the container in interlocking patterns to maximize space and maintain balance during shipping. Once fully loaded, the cargo container is sealed with a serialized lock, ensuring tamper-proof transport. The container is lifted onto a waiting truck for outbound shipment, marking the final chapter of the Purifier's